Hello guys, this is Curly. In this video, I will introduce key idea of quicksort algorithm and show the implementation details with the recursion method. In this lecture slide, we have a couple of topics to talk about the quicksort, but in this video, we are going to jump into main topic, the quicksort algorithms directly, and then I will talk about the implementation with the recursion method. The basic idea of a quicksort algorithm is related to the concept of divide and conquer. Key concept is to split the array into the two sections according to the pivot value. First, we need to choose the pivot value. In this algorithm, we just use the last element in the array for the pivot. Once we choose the pivot, the array will be split into two sections. All elements in the left subarray are less than the pivot value. On the other hand, all elements in the right subarray are greater than pivot. Once we finish the split work based on pivot value, we are doing the same work upon the left and right subarray respectively. We keep doing a kind of same work until there remains one element in subarray. Now let's take a look at a typical quicksort example. Here is an integer array with 7 unsorted elements. We are going to set last element as a pivot value. Now we divide the array into two subarrays in such a way that all elements in left section are less than 7, and all elements in right section are greater than 7. Now we have the split two subarrays. First, we are doing the same work for the left subarray, and then after finishing the left section, we are going to do quicksort again for the right section. Now let's do quicksort for the current left section. The pivot value will be the last element again. In this left subarray, the pivot is 3. Hence, let's divide this array into two sections based on the pivot value 3. And here are partitioned two subarrays. After that, we are trying to quicksort for the left section, but there is just one element in left subarray. Thus, we need to stop the quicksort for this subarray and then return to the work for the right subarray. Now we are going to start quicksort again for the right subarray that has the value 4 and 5. At this time, the pivot is 5 and the partition will be working for this array. Since there are just two elements and the pivot is greater than the other element 4, there is no change after the partition. After this partition, since the left subarray has just one element and there is no right subarray, all these subarrays sorted completely. And then we are going to return the first right subarray that has the value 9 and 8. Now let's get started to quicksort for the first right subarray. The pivot is 8. There is just one element 9 other than the pivot. Thus the partition makes just one right subarray like that. And now there is no more subarrays to do quicksort. Now we are going to return to the main work and finish the quicksort. And here is the brief sketch of algorithm for quicksort. Quicksort has 3 steps. The first work is the partition. The partition makes the array into two subarrays based on the pivot value. After the partition, in the step 2, we are doing the same work for the left subarray, and in the step 3, we are doing again for the right subarray. The next video is for the partition algorithm. Let's take a look at details for the partition. In this video, we will learn about the partition algorithm in quicksort. We will use two indices. The yellow index is for the last index for the smaller part, and the white index is for the traverse in this array. We are going to start compare the pivot value 7 from the first element. In this example, the first element is less than pivot, thus we move the smaller index to the first position. After the comparison to the second element, if it is greater than 7, we skip this element. For the third element, if it is smaller than 7, we need to swap two values. After the swap, the last index for smaller part increases 1. And we continue to compare the next element. The next item is greater than pivot 7, thus we move to the next element. Next item is smaller than 7, we should swap two values and then increase 1 on the last index. We are going to check the next element. It's smaller than pivot, hence we swap again two values and increase the last index. After the iteration, it's time to place the pivot value. We move it to the next element to the smaller part. And now the partition is complete. Based on pivot 7, we have two sub-arrays. The left is smaller and right is greater sub-array. We talked about the key algorithm of quicksort. Now I will show the detailed programming code with the recursive method. In this video, I will make the program code for quicksort with recursion. First, we are going to declare the function prototype for two functions, the quicksort and partition. In the main function line 11, we call the function quicksort for the first time. Quicksort function has the code for the termination condition and 3 steps. We will stop the recursion when the start index is greater than or equal to the last index. And then we call the function partition and two quicksort functions for the left and right subarrays. And now we are going to make the code for the function partition. We are going to use two variables I and j to control the index of an array. The variable I is used to denoting the last index of the smaller section, and variable j is used to traverse the array. During the iteration, if we find the element that is less than the pivot value, we are going to swap two values. In this example, the value 8 and 5 are going to change to each other. After the while loop, the pivot is still in the last element. The pivot should be moved the next to the after the smaller part. Here is the end of this video. If you want to watch the more details of the performance analysis, please watch the next video, Quicksort Algorithm Part 2. Thank you for watching this video.